Welcome to Shri Sathya Loka Seva Gurukulam online classes. So we've been learning limits and continuity. So let's quickly move on to today's class. Okay, in today's class, we are going to see limit of some important functions. So if you see, we've seen when we substitute the limit into direct substitution of the function and get an indeterminate value, we have to every time rewrite the same function in different ways, rationalize it or factorize it, cancel out the factors that are giving you hindrances and leading you to an indeterminate form. So we keep rewriting it. If you see, certain times rewriting becomes very, very difficult for us. We will not be in a position to even simplify it. So for those, with various other methods, few standard functions have been evaluated with limits and few formulas are already ready-made for us. We can use them, okay, and then evaluate the functions. So it becomes easier for us so that we need not keep simplifying, and if it becomes impossible for simplification, we will not get stuck. Okay, so that's the basic idea behind this lesson. Okay, so the first and the foremost important function is that x bar n, limit x tending to a, x bar n minus a bar n by x minus a. So now let me give you an example. Let's suppose I have limit x tending to 2 bar 5, x bar 5 minus 2 bar 5 divided by x minus 2. So this is my function, let's suppose. Okay. So now when I substitute the function, the value of x directly and see what happens. So this becomes 2 bar 5 minus 2 bar 5 by 2 minus 2. It is leading me to 0 by 0 form. Now simplification of this is going to be very, very difficult for me because a power 5 minus b power 5 formula and all are quite complicated. When I have very large n, meaning the power is very big, 32, 40 and all that, evaluating them, simplifying them becomes practically really impossible. So in that case, after the complete solving of the limits with certain methods. So the methods we are not going to discuss here because it will take long and it's not there in your syllabus too. So we're not going to discuss all that now. So we are just going to use this formula and solve the problems. Okay. So x bar n minus a bar n by x minus a. So this is of that form. See, x bar n, your n is 5. Every bar is just 5 here on the numerator. By your x is x here and your a is 2 here. Right? Your a is 2 here. So we have this limit ready-made given to us, limit x tending to a. Your x is also tending to the same a value here, that's 2. X bar n minus a bar n by x minus a is going to be n a bar n minus 1. So here it is going to be n, that is 5. My a is 2 bar n minus 1, 5 minus 1. So it's going to be 5 into 2 bar 4. So this is 5 into 16. That's nothing but 80. So I've directly found the value of the function. Otherwise, simplification and then application of the limits is going to be very, very complicated in this case. So we have a standard limiting value that's been given for some special functions. So these special functions, please do make a note of it, and we need to identify them properly in the function that's given to us. If possible, rewrite them in this format so that the application and finding the limiting value becomes very, very easy for us. So shall we move on? This is the first important function. Please make a note of it. Let's move on to the next function. The next function is this. Limit x tending to 0, sin x is equal to 0. This is very, very simple. When you apply the x limiting value itself, a direct substitution gives you the answer. Sin 0 is 0. You all know it very well. So limit x tending to 0, sin x is 0. Now the next one is limit x tending to 0, cos x, that's also equal to 1. When you substitute 0, x as 0, you get that cos 0 is 1, right? So now the next one. So now this is a very special function. Limit x tending to 0, sin x by x. Now when I substitute directly the x value, what happens to it? Sin 0 by 0. You always know that sin 0 is 0. It gives you 0 by 0 format. It becomes an indeterminate form. You will not be able to evaluate. So this particular result is very, very important. So limit x tending to 0, sin x by x is 1. Okay, your book has these results. You can go through it and see if you are able to understand how these limits have been evaluated. Okay, so the next special limit is that limit x tending to 0, 1 plus x, the whole raised to the power 1 by x. So what happens? 1 plus x, 1 plus 0, the whole raised to the power 1 by 0. That is, anything raised to the power infinity is not going to be determined. So this is again a special value. So 1 plus x, the whole raised to the power 1 by x is equal to e. The next special function is that e power x minus 1 by x. Limit x tending to 0, e power x minus 1 by x is equal to 1. If I directly substitute the limits, what do I get? E power 0 minus 1 by 0. That is, anything power 0 you all know is 1. So 1 minus 1 by 0 is 0 by 0 format, which is going to be indeterminate. So definitely when you get functions of this form, you need to use this particular limiting value. So always remember, limit x tending to 0, e power x minus 1 by x is equal to 1. Now the next function that's important. Okay, so this is the last function that we've seen. So I hope you all remember all the functions that we've seen. If you have any challenges, go back to the previous slides and you can make a note, list all the special functions that we discussed now so that we can move on solving the questions. The first question for the day is limit x tending to 0, e power 2x minus 1 by x. Now, have we seen any function of this form? Have we evaluated or seen any function of this form in the special functions that we discussed now? So, is this similar to it? E power x minus 1 by x is equal to 1. Aren't we seeing a very similar function? So, let me write that. We know that limit x tending to 0, e power x minus 1 by x is equal to 1. Okay. So, is this just similar to this question? Very much similar to this. It's similar but not the same. If you see, here we have 2x and here we have just x. But according to this function, it says e power x minus 1 by x. So, whatever variable comes here, the same variable needs to repeat itself on the denominator for you to get a value of 1, right? So, limit x tending to 0, x tending to 0 is the same. But the function has to be rewritten. So, I need a 2 here for me to apply this formula, correct? So, if I have to get a 2 here, so what do? I decide to multiply and divide this function by 2. I'll rewrite this function. I'll just multiply and divide it by 2. So, I do it as 2 into e power 2x minus 1 by 2 into x. Okay. So, now this is a constant. So, I'm going to take it out of the limit. So, I'm going to write it as 2 limit x tending to 0 e power 2x minus 1 by 2x. Is this of this form? Yes. This is also 2x, this is also 2x and e power 2x minus 1 by 2x and the limit is x tending to 0. So, now I can apply this and that is equal to 1, right? So, this is equal to 2 into 1 and I get a value of 2. So, limit x tending to 0 e power 2x minus 1 by x is 2. I hope you understood. We'll move on to the next question. Okay. Now here if you see, I have e power x minus e power minus x, by e power x plus e power minus x. Now, involving exponential functions, do I have any formula ready-made for me with limits so that I can apply? I have only one formula that we've already seen, that is limit x tending to 0, e power x minus 1 by x is 1. Now, if I directly apply the limits here and see, I get e power 0 minus e power minus 0, that's again 0, by e power 0 plus e power minus 0, that's again 0. So, this is 1 minus 1 divided by 1 plus 1, and that's going to be a 0 here, right? But let's see what happens when we apply the limits and see, okay? So, now the next question. Limit x tending to 0, e power x minus e power minus x by e power x plus e power minus x. So, I have too many exponential functions here. Do I have anything ready-made formula in the limits that I saw so far that I can use here to find the limits? I have one involving the exponential functions that we've already seen in the previous question, that limit x tending to 0, e power x minus 1 by x is equal to 1. But if you see, observe here, I don't have a 1, I don't have a denominator and things like that. Let me first solve this and see, rewrite this and see what do I get. So, this is limit x tending to 0, e power x minus 1 by e power x, right? E power minus x is 1 by e power x by e power x by 1 by e power x. So, now let me simplify this further. I can take LCM on the numerator. So, I take e power x as the LCM. I have e power 2x minus 1 divided by, on the denominator again e power x is the LCM. I have e power 2x plus 1. So, e power x gets cancelled and I have limit x tending to 0, e power 2x minus 1 by e power 2x plus 1. Now, again, I cannot apply any of these formulas, okay? But if I have of this form, I can do it. So, I need a 2x on the denominator for me to convert it into this form, right? Both the numerator and the denominator should have 2x on its denominator. So, what I'm going to do is, I'm going to divide both the numerator and the denominator by 2x. So, whatever I do to the numerator, I can do it to the denominator, right? So, I'm going to rewrite this as limit x tending to 0, e power 2x minus 1 by 2x divided by e power 2x plus 1 by 2x. So, now I can apply limit both to the numerator and to the denominator. This gives me 1 and this gives me 1 and I get an 1 as the answer. I hope you understood this. The next question. Find the value of each of the following. Okay, so the second question, this particular question that we are going to solve now, e minus e power x by x minus 1. So, which formula I have very similar to this? It's limit x tending to 0, e power x minus 1 by x. See, here my x is tending to 0, but here it is tending to 1. And my denominator is just x here, wherein it's x minus 1 there. So, now I need to rewrite this, otherwise I cannot bring it of this form because I have only 1 for my exponential functions. So, what I'm going to do is, I'm going to substitute x minus 1, whatever here, with one single variable. Let me choose it as h. Okay. So, according to this, x is tending to 1. So, what happens when my limit x tends to 1? My x minus 1 will be tending to 0 or my h will be tending to 0, correct? So, now I'll rewrite this function with a different variable. So, my h will tend to 0 because I'm going to write it in terms of h. I cannot involve an x limit there, okay? So, I need to convert the limit also into h. So, e, there is no change in e because it's a constant. It doesn't have a variable. Now, e power, my x has to be changed to h, right? So, x minus 1 is h, my x is h plus 1, correct? So I'm going to rewrite x as h plus 1 divided by my x minus 1 becomes h. So now how do I rewrite this? So this is nothing but e minus, I'm going to use the exponential law here. When I add up the power, it is as good as when I multiply two exponents of same base, I add up the power, right? So e power h plus 1 can be rewritten as e power h into e power 1 by h. If you observe, e is common out here. Let's take that out. So you have limit h tending to 0, e into 1 minus e power h by h. So e is a constant and it's a coefficient. You can bring it outside the limit. So e limit h tending to 0, 1 minus e power h by h. You know that e power x minus 1 by x is 1, right? X tending to 0. Now I have it the other way around. I'll rewrite that. I'll take the minus outside. So I'll write this as minus e into limit h tending to 0, e power h minus 1 by h. When I substitute the limit, I get into 1 and my answer is minus e. So have you understood? So such functions, we have easy formulas to calculate the limits, evaluate the limits, okay? So these formulas needs to be memorized. Okay, the next question. Now it says x tending to 0, sine 4x by 2x. So when I substitute the limits, I'll definitely get to 0 by 0 format and I have sine 4x by 2x here. Simplification becomes very, very difficult for me. So what do? Do I have any special limit formula that I've seen? I have seen a formula involving trigonometric formula, right? Trigonometric ratio. We've seen that limit x tending to 0, sine x by x equal to 1. Here I have sine 4x by 2x, but it says sine x by x. So whatever angle comes here, the same angle value should be on the denominator. Okay, so these formulas are trigonometric, involving trigonometric ratios. The angles are given in radian form. Please remember, these are not degree measures, these are radian measures. Okay, so now I have the angle value is 4x here, then the denominator should also be 4x. But here I have 2x. So how do I convert it into 4x? I need another 2 there. So I'm going to multiply and divide this particular function by 2. So 2 sine 4x by 2 into 2x. I'm just rewriting the function. So I'll get limit x tending to 0, 2 sine 4x by 4x. Now this 2 is a constant, I can take it out. Now I've got it of the desired form. I have my special function here, sine 4x by 4x, and the limit is tending to 0 and I have the limiting value as 1. So 2 into 1, 2 is my answer. So this is equal to 2. So I have a special formula here involving trigonometric ratio. This is very important. Problems based on this are very, very important. So please keep this formula in mind when you solve problems involving sine x especially. Now let's move on to the next question. Okay. Now it says limit x tending to 0, sine x square by 5x square. So what's the formula that we know? Limit x tending to 0, sine x by x. So whatever angle value is here, the same value should be there on the denominator. I can see that. But there's one extra, that's my 5. It's a constant coefficient. I can easily take that out. So I can write this as 1 by 5 limit x tending to 0, sine x square by x square. So you know limit x tending to 0, sine x by x is 1. So this part is going to be 1. So 1 by 5 into 1. My answer is going to be 1 by 5. Easy, isn't it? So if we know the formula, it becomes very, very easy. The next question. Sine 2x into 1 minus cos 2x by x cube. So this, we have various identities also in trigonometric identities that you have learned, correct? We'll put it into simple ratios so that it's easy for us to evaluate that, okay? Because it says sine x tending to 0, sine 2x, but on the denominator it is x cube. If I have a 2x, I can easily evaluate. And there I have a cos 2x. So if I substitute the limit, that becomes 0. So that becomes 0 because here cos 2 into 0 is cos 0 is 0. So 1 minus 1. Cos 0 is 1. So 1 minus 1 is going to be 0. 0 by 0 format it will take me. So now what do? I have to simplify this. So let me use the identities that we learnt, okay, in trigonometry. So now sine 2x. Looking at sine 2x, do you all remember any identity that you have learnt? It is 2 sine x cos x. Okay, so let's rewrite that first. So I have limit x tending to 0, 2 sine x cos x into 1 minus cos 2x by x cube. Okay. Again, my problem is not solved because this 1 minus cos 2x, it's again going to give me 1 minus 1, that's 0 by 0 format. This is of no use. I cannot, separate this x. If I separate this x, again I have a x square here, which is going to give me a 0 only. So what do? Are there any other scope of applying identities? Of course I have 1 minus cos 2x. 1 minus cos 2x is 2 sine square x. Let me try applying that and see what happens. So this becomes limit x tending to 0, 2 sine x cos x into 2 sine square x by x cube. Okay, let me simplify this. So this is limit x tending to 0. This is 2 into 2, 4 sine cube x cos x by x cube. So now what can I do? I can split the limits now. It becomes easier. Let me take this constant out. So I have limit x tending to 0, sine cube x by x cube. So I can write that as sine x by x the whole cube. Right? That's sine cube x by x cube. Okay? Into, I can write it as limit x tending to 0 cos x. Right? So sine x by x gives me 1. So this is 4 into 1. And limit x tending to 0 cos x is also going to be 1. So this is going to be 4. Correct? So my answer is 4 here. So have you all understood? So what we've basically done is we've applied trigonometric identities to rewrite of the desired format, wherein I can apply some special limit identities, formulas that I have to evaluate the limits easily. Otherwise, it's giving me an indeterminate format. So sine 2x, I'm rewriting it as 2 sine x cos x, and 1 minus cos 2x, again I'm rewriting it as 2 sine square x. So when I multiply both, I get 2 sine cube x cos x by x cube. So I decide to club these two because I know that limit x tending to 0, sine x by x is 1. So I'm going to write this as sine x by x the whole cube. Limit x tending to 0, cos x is 1, that also I know. So when I apply the limits, I don't get a 0 anywhere or 0 by 0 anywhere. So it's 4 into 1 into 1, that gives me a 4. I hope you've understood whatever we did in today's class. So we've learned some very, very important formulae in limits today. So these special functions are very important, and limits to these special functions are to be written on a notebook and used wherever required. So make a note of it. In case you have any confusion, you can go back through the video and listen to the explanation once again and make a note of it and then see if you've understood. Thank you. Sai Ram.